Welcome, everybody. This is Let Your Data Do the Talking with Deanna Schneider and Christine Ryback. I am your moderator for the session, Amanda Thornton. I'm a software developer, so I'm very anxious to see this session. I'm all about data and how we can use data and how we can help it work for us. Christine Ryback is a teaching and learning with technology specialist in the Educational Technology Support Unit within the Division of Extension. Christine works with extension educators and others to improve instructional design and technology integration in face-to-face and online learning environments. And Deanna is a software and data engineer with the Office of Educational Technology Support, and she builds data collection applications, conducts data analysis, and integrates disparate data systems, of which we have many. Thank you, Deanna. Welcome to the session, and take it away, Deanna and Christine.
All right. You should see my screen shortly. I think we see it. Yep. Okay, so today we're going to talk a little bit about helping your data do the talking. So when does data talk? Next slide, Christine. Sorry. It's all right. Data talk. Yeah. Data talks when it's turned into effective visualizations and when it's accompanied by a compelling narrative. When those three components come together, the data, the visualizations, and the narrative, we call that data storytelling. Those three components help data storytellers engage the audience, make data more memorable, and be more persuasive. Let's give you a quick example of one time when it didn't go so well. Sure, you've all heard of this guy, right? He's Ignaz Semmelweis, total household name. No? You haven't heard of him? All right, that's because Semmelweis, though making a great discovery, really had no long-term effect on anything. Semmelweis lived in the 1800s, before we understood microbiology or germs. He worked in a hospital in Vienna that had two clinics, one clinic that trained doctors and medical students, and one clinic that trained midwives. Patients, when they came in, were randomly assigned to each clinic based on the day they arrived. Semmelweis noted that the death rate in the clinic that was training doctors far exceeded that of the clinic with the midwives. He also noted that in the doctor's clinic, students started their day by performing autopsies on the mothers that had previously died. Afterwards, they would then go to the clinic upstairs and perform their exams on the current patients. And they did not, as a practice, wash their hands in between. No autopsies were performed by the midwives. Ew, right. Yep. Well, Semmelweis didn't actually know about germ theory because we didn't know what germs were yet. He postulated that maybe there was something being transferred from the cadavers back to the mothers. And so he implemented a hand washing policy for all the doctors and students in the clinic. And as you can see here, the death rate plummeted. They even had some months with no deaths at all. But in 1849, Semmelweis was dismissed. Turns out he was apparently not the easiest guy to get along with, and he didn't always have excellent communication skills. So his friends tried to convince him to share his data with other doctors. But he waited 13 years to publish anything, and when he finally did publish, what he published was 500 pages long and contained the table of data you see on the screen. And not surprisingly, nobody cared. He had good data, but he didn't tell a good story. Modern antiseptic practices weren't routinely used until 40 years later. Consider all the lives that could have been saved had Semmelweis done a better job of telling his story. Now, our data might not be quite so life and death, but we can learn from Semmelweis's mistakes and try to learn how to let our data help us tell our stories. So let's learn a little bit about what makes your visualization tell a good story.
All right. This is my area of learning science, and when we talk about cognitive load, it becomes a factor in telling stories with data. So what cognitive load is, simply defined, is the amount of mental energy that it takes to learn something new. So there are three things that we want to consider when creating with stories, and that idea of cognitive load. One of the considerations is the complexity of the data itself. Is the data set easy to explain, or is it super complex? Second, we want to consider is the familiarity of the audience. If the audience has a good sense of the information that's being presented, then it lowers the amount of cognitive load it takes to learn something new. And then finally, the one we'll discuss here today is that can add to cognitive load is the design of the visualization itself. So the complexity, the color, the contrast, all of those things can make a difference and distract from the story that you're telling if you have a very complex visualization. So we will be focusing on telling a compelling story without that distraction.
All right, so we're going to go over 5 tips today to help you create more effective visualizations to tell your data story. Most of the examples that you'll see today that were created by us were created in Excel using data that I pulled from our internal planning and reporting system. This is data that we just knocked over my water bottle. This is data that we collect internally about the demographics of our participants. It's fairly simple data. We wanted to keep that cognitive load of the data low. So while you're not familiar with our internal systems, I think you'll be familiar with the same kinds of data that we're collecting. There are far more powerful visualization tools out there than Excel, but I wanted to demonstrate that you don't have to have a fancy piece of software to create clean and compelling visualizations. The pretend audience for all these visualizations is our internal stakeholders who are already familiar with the kinds of data we collect. You can imagine that we might be sharing this data with our administrators, talking about how well we're doing with collecting our demographic data. So we're going to go over these 5 tips, and we'll cover each of them in depth more, but we just want to share with you first what the 5 tips are. So the first one is keep it simple. And the second one is use color wisely. The third one is use text to support your narrative. The fourth one is use the right kind of chart. And the fifth one is be honest. So let's jump right into that first one, keeping it simple. We've all had conversations with consummate storytellers that tell their stories like this. They have a point, and eventually they get to their point, but you'll go on a fantastical, circuitous journey before you get to the point. Contrast that with storytellers who tell their stories like this. They go straight from the start to the end in a clean line. Usually when we're using data to tell a story, we want to use that straight line approach. We want to keep it simple. We don't want our audience to have to work to get to the point. But often as visualization designers, we think that bells and whistles and shiny bits are pretty nifty, and it's really easy to go overboard with our visualizations. Let's look at an example of a not simple visualization, one that has a whole lot of that cognitive load Christine talked about, and then we'll look at some techniques we can use to improve it. So this is an example of a visualization that has a lot of cognitive load. And before you assume that I intentionally made the worst thing that I could, know that this is primarily an out-of-the-box template from Excel. You too could click a couple of buttons and wind up with a visualization like this. When you look at it, what do you think it's trying to tell you? And how long does it take you to get that info? And feel free to put it in the chat or unmute. What do you think this visualization is trying to tell you?
I think it's taking a long time for a reason.
I do think it's taking a long time for a reason.
Yeah.
Still absorbing the content. Exactly. Yeah, there is a lot here. Some of what? Yeah, I don't some. I don't know. The legend being in a different order than the bars is already driving me nuts. Yeah, there's so many things wrong. So there are ways that we can combat. Yeah, it's got an unclear title, number of employees by gender. It's not number of employees by gender, but yeah, you might as well guess that because it doesn't actually say, does it?
No.
Yeah, it's very confusing. Okay, so let's look at some things that we could do to make this better. The first thing that we want to do to combat cognitive load in our visualizations is to eliminate what we call chart junk. Chart junk is anything that's there just for decorative value, but doesn't actually add to the story that we're telling. In this chart, that means eliminating the 3D effect, removing that background shading, simplifying the bar labels, and removing the filters. This is just like a printed visualization, so those filters aren't going to do a thing. So the next thing that we can do is eliminate duplicate information. Right now, both the grid lines and the printed numbers at the ends of the bars identify the total participants. The bar labels and the legend identify what each bar represents, and we should eliminate the duplicate value for each. So I think that you'd agree that this is a vast improvement over where we started. We're not done yet, so you'll see additional improvements in our next few steps, but this is way better than what we started with so far. Let's go on to our next tip, which is to use color wisely. Color is one of the most effective ways to draw someone's attention to what's important. We as humans have naturally evolved with color vision to help us navigate the world. Imagine you're an early hunter-gatherer and you're out in the woods and it's a sea of greens and browns and you're looking for some edible berries. What color are they? They're probably somewhere in the red family. Red is complementary to green, and that red color is going to really pop for you. Now, I don't recommend using red and green together in your visualizations because people with red-green color blindness will struggle to see your story. But red and gray or black can be a powerful combination, or really any bright contrasting color combined with gray or black is great for drawing your attention. Let's look at an example. If I ask you to count the 8s in this graphic, you'd probably struggle to do it. Anyone know how many 8s there are? Take a second and try to count them. Yep, Lorianne got 8. Anyone else get anything different?
Lorianne's quick that way.
Yeah, so there's nothing to draw your attention to the 8s in here, but if I asked you to count the 8s now, it's a fairly easy task because we've used color to draw your attention to what's important. Now you can go overboard on color, and as soon as you do, your eyes will lose focus again. This is a visualization I saw out in the wild the other day. There are a number of things wrong with this, but let's talk specifically about the issue with color. The colors represent the rankings for the 50 drunkest counties in the US. You might not be surprised that Wisconsin has a lot of those. A lot of our counties are in the top 50. But you might imagine that red is associated with the worst of the worst. Sort of a common understanding that red is like a danger color or a caution color. But in this case, it turns out that red is the best of the worst, meaning that the red counties ranked lower. And you can't see that until you like zoom in, click to the, yeah, there we go. Click on the legend and you can see that the red is the least worst of them. So here they've used a technique of just using really random colors to represent the categories, which is kind of confusing. But let's take a look at what this visualization would look like for someone that's green colorblind. I think most of us would be hard-pressed to differentiate between those two darker green tones. This visualization is a prime example where using a gradient instead of separate colors would convey a clearer story. So here's a version of the map using the same data, but using a single color gradient in which the drunkest counties are the darkest counties. Gradients aren't great for identifying precise ranking, but they're really good for just giving a general sense of more or less. And so in this one, the darker the color, the more binge drinking. And as you can tell, Green Bay is right up there with the bingiest drinking groups of all. I wonder why.
And Eau Claire.
And Eau
Just saying,
Claire,
it's my
yeah,
home.
just saying it's true.
Just saying.
Yeah.
Yeah.
So how can we use color to improve our own visualization? Well, currently we just have a bar, each a different color, and those colors don't actually mean anything, and our eye isn't drawn to any particular color. If we truly want our viewers to look at all the bars in a bar chart, the best approach is just to make them all the same color. But often what we're interested in doing is calling out a certain aspect of our data. What story does it tell if we do this? Anyone want to shout it out or put it in chat? What story does that tell? Significance? Emphasis? Yeah. What are we emphasizing? That female is the highest value in the data collection. Yep. Yep. And if we did this, in this case, we're emphasizing, yeah, the unknown is the lowest value, or that we're emphasizing that the unknowns for some reason. We still don't really, calls out the lack of data collection, right? We still don't really know like what this visualization is about or why we're emphasizing this. So that brings us to our next tip. We can use text to support our narrative. As you saw on that last slide, changing the bar color changes the story that our data is telling because we're highlighting a different part of the visualization, but we can use text to support that narrative as well. So data storytelling, unlike simple data visualization, is meant to be persuasive. We, as the owners of the data and the developers of the visualizations, we've already had some insights about the data, and we're using the visualization to help share those insights. And the easiest way to do that is to make it bloody obvious. Perhaps our insight with the data is that we're still struggling to get people to provide their demographic data. And if so, we could do something like this. Here we're calling out that almost a quarter of our participants do not supply the sex information. But perhaps our insight is that compared with how we'd done last year, we have more information this year, and then we might add a title like this, where only 23% of our participants do not supply sex identification. It's the same data point represented in two different ways, and the text helps us craft that narrative that we're trying to convey. In either case, you'd often be using these visualizations within a broader context, so your title should be obvious within that context, and you should guide your viewers to the point that you're trying to make. So tip number 4 is to use the right kind of visualization. At the UW, we love our research. And of course, multiple people have done research on how humans perceive quantitative information in graphical representations. The most famous research was done by a couple of scientists named Cleveland and McGill. And they broke down the elements that you would find in a data visualization into 9 different components. And then they ranked them as to how accurately humans are able to extract information from a visualization using each of those elements. Before I show you the results of their research and talk about how it should influence your choice of chart type, let's do a little research of our own, a little informal research. We're going to look at some chart types and try to answer some questions. So here's the first one. Looking at this pie chart, who can tell me which slice is the smallest? And if you're really good, how much smaller is it than the largest slice? We got a guess of yellow, another guess of yellow. Any guesses on how much? Or gray? We got a guess of gray. Yellow by 10%. Less than 25%. Yeah. So yellow is the smallest slice. It is only 7% smaller than the largest slice, which is the orange one. So this is the same data. Which is smaller, the blue slice or the gray slice?
Oops, sorry.
Nope, next one, Christine.
Yeah. This one.
That one, yep. Which is smaller, blue or gray? Got a guess of gray. Guess that they're the same. Yellow's not one of the options, Heidi. Yeah.
Eye
Okay.
doctor.
Yeah. Nope. Yep. So the blue is smaller by 1%. Finally, when we present the data this way, next slide. Now you can actually see this is all the same data, all the same bars, But when we put them on a common axis, now you can see fairly easily which one's the smallest, which one's the largest, and that blue and gray have a very slight difference between the two of them. This is all right in line with what Cleveland and McGill found. So here's the results of the Cleveland and McGill research. They rank the various chart types from those that are the hardest to interpret on the left to those that are the easiest on the right. A pie chart is an example of a chart that uses the angle element. And it lands about in the middle of the scale from least to most accurate. I would argue that it also uses a bit of the area element, but that's even lower on the accuracy scale. The chart with the randomly placed bars, that would fall here. So it's easier for humans to assess the length of something than the angle of something, but when we place the bars on the common axis, we bump ourselves all the way over to here. Bar charts are often the go-to chart for representing numerical information, and for good reason. Our brains just naturally interpret data presented this way with the most ease. So that's not to say that the elements on the left of this visualization should never be used. Shading or color saturation are often used in map visualizations. You just saw an example of that a few slides ago. But they should only be used where the exact number isn't important, and instead you're just going for that general sense of less than or more than. Similarly, for our data, if we want people to understand the raw numbers in each category, then a bar chart is the most appropriate. But if the story we're trying to tell here is about percentages and we only have 2 categories, this is one case where a pie chart might actually be better. Here, a pie chart allows us to easily compare the unknowns with both categories of knowns. And since the story we're trying to tell is about the unknowns, we might not want people to get caught up in the other story that we could be telling about how we have almost twice as many females as we have males in our audience. Also, knowing your audience is important. There are certain audiences that love their pie charts. If you're presenting simple data, not more than 3 categories, to an audience that likes pie charts, and you can supplement the graph with numbers, like here we've added the 23%, then go ahead and use the pie chart. Knowing the strengths and weaknesses of how people interpret the graphics and knowing your audience will both help you choose the right graph for each story you're trying to tell. So our final tip, it might seem simple. Of course, you'll be honest, right? But there are many ways you can inadvertently be dishonest in your visualizations, particularly if you haven't spent a lot of time thinking about the normal conventions of visualizations. Let's look again at our visualization above on the screen. There's an assumption that you've probably made, even if you don't know that you've made it. Does anyone know what it is? Axis starts at 0, right, David? So yeah, if we look at the next version of this, the numbers at the end of the bars stay the same, but this is a dishonest visualization because the axis doesn't start at 0. We look at the next version. This is slightly more honest because we're actually calling out where our axis starts, but people still expect the axis to start at 0. So when they see this sort of a thing, it amplifies the differences between your bars in a way that's not true to the data. There might be some instances where you could do this if you identified where your axis really started and that very small differences were actually meaningful in your data. But in general, there'd be other better ways to display your data, such as a % difference from the scale. Yeah, there's lies, damn statistics. Yep, exactly. Yeah. You might think this kind of visualization dishonesty is rare, but there's actually plenty examples of this and other kinds of visual trickery out there. We're going to look at a few more. So here's another way Viz creators can be misleading, and that's through dual axis graphs. This chart shows home runs versus intentional walks by season. And at first glance, it looks like there were more intentional walks than home runs back in the 80s, but that home runs have more recently taken over. But if you look really closely, there are actually 2 scales, one on the right and one on the left. If we use a single axis for each of these, you can see how different the picture really is. Walks have never exceeded home runs, and the number of intentional walks doesn't vary as much as it looked like it did in the first graph. So you need to be just really careful with dual axis graphs. It doesn't mean you can never use them, just means you need to be really careful about the story that you're telling when you do use them so that you're not being dishonest. This next one is a standard in the What Not to Do lectures when we talked about data visualization. It was actually created and used. It was created to illustrate Florida gun deaths before and after the Stand Your Ground law went into effect. And for reference, if you don't know, the Stand Your Ground law is a law that allows people to use lethal force legally if they fear their life is in danger. So intuitively, you might expect gun deaths to increase when that happened. And what do you see here? What's going on? Does it look like they increased or does it look like they decreased? Right now, yeah. So it looks like they decreased, but it looks like they decreased because the graph is upside down. If we look at it the way people normally look at graphs, where 0 is the baseline instead of 0 being at the top, it's quite obvious that they increased a fair amount. This was a controversial topic at the time, and people didn't want to have the public understanding that the gun deaths increased that much after this law. So they used a dishonest visualization to convey the data. Here's one more example. This one's a little bit trickier. At first glance, it looks like it shows the percentage of participants in each race, and there are clearly percentage symbols on the labels. Can you see what makes it dishonest? Math. Yeah. Math. Yep, it's the math. They do not add up to 100%. Christine, you want to hit the next one?
Yeah.
There you go. Yeah. So this isn't something that I think would happen if you were using raw data, but in Excel, if you already have your data coded as percentages and you throw it into a pie chart, you can have this happen in a way that it's just not right. You know, it ends up being there's more than 100% in your pie chart. If you're using numbers that add up to more than 100%, then you shouldn't be using a pie chart. Yeah. And Scott, I really hope that gun death visualization was like an example of bad data in Data is Beautiful subreddit.
Mm-hmm.
Sadly, I'm guessing not. Okay, so we ran through these 5 tips pretty quick. Keep it simple, use color wisely, use text to support your narrative, use the right kind of chart, and be honest. And I think we have 2 minutes left for questions, if anyone has any.
Stop.
Best visual recommendation for data over time. Depends on what kind of, like, I'm not sure what you're trying to show with the data over time. Usually that'd be a line graph of some sort for data over time. Yeah, thanks for that link, Amanda.
Yeah, Tableau has some good, well, has a lot
Mhm.
of good resources there.
Yeah.
I have a quick one about, I always have this trouble of how do I provide enough context so
Mhm.
that the audience knows what I'm talking about without providing too much so that they're overwhelmed.
Right.
And I seem to err on not enough context. People don't know what I'm talking about.
Yeah, it's a hard balancing act, and that's a lot of that. It's knowing your audience and knowing like how much context they need. It's also a whole lot easier if you're using your visualization in a presentation where you can add some ad hoc context. If you can't and you just have like a written, you know, or like a printed visualization, you can always have like a supplemental piece of textual information that explains your context for you. Generally speaking, on a printed visualization, I'd want to see the source of the data, which I'm not showing in here because I've simplified all of these visualizations. Yeah, so I'd want to see the source. I'd want to see like what your takeaway is from the visualization, like what, you know, what is your title headline, the one thing you really want me to take away. And then the additional context is really dependent on your audience and the data.
I've had pretty good luck putting it in front of someone else. Like, do you know what this says? And then
Yeah.
having a conversation about what's missing too, like somebody
Yep.
that doesn't know what you're talking about.
Yeah,
initially.
that's always a really good thing to do, is to show it to somebody who's not familiar with your data. I see that there was a comment that your audience should be able to understand it at a glance. Absolutely. If you are trying to convey one concept, then understanding it at a glance is the way to go.
One very quick question, thoughts on motion graphics and data?
I'm not really familiar I'm not sure what you mean by motion graphics.
Like slight animations, Sergio? Oh, so animations.
Animation. I mean, animation can work well if you have the right kind of data and the right kind of audience, right? So there's for all of these things, there's no like hard and fast rule. That's all super contextual. I've seen some really excellent examples of animation where it's like explaining concepts, like how quickly, I saw some really great ones that showed how quickly a virus can move through a community, where it was just a circle with a bunch of circles in it, and then you'd inject like one person with a viral load, and you could watch how it traveled through the community based off of different kinds of algorithms. And that can be great. Other places I've seen animation just be really bells and whistles that isn't necessary. So if your animation is needed to understand the concept, by all means use it. If it's just bells and whistles, I'd steer clear.
Yeah, chart junk again, right?
Chart junk again, yeah.
It adds to cognitive load.
Yep.
Yeah.
Well, we are at time. We're a little bit over time. Thank you both for this presentation. It was wonderful. The story right at the beginning just really grabbed me. That was fantastic. Thank you. This is our last session for the day, but we got a whole bunch of, trying to think of a better word there, lots of great presentations tomorrow, including the IT Awards first thing in the morning at 9 o'clock. We'll be handing out some recognition awards for some folks. I hope everybody can join us for that one. I don't think so. If our Deanna and Christine, are you open to people have questions of them contacting you?
Sure, of course.
And I think both of you are named first, not last at Vista.edu.
We sure.
No. Great, wonderful. Thank you. Thank you
You're
very
welcome.
much. And thank you for everybody for coming.